In 1933, a Swiss astronomer named Fritz Zwicky was staring at the stars, but something was deeply wrong. He was observing the Coma cluster, a massive collection of galaxies, hundreds of millions of light-years away. He calculated the mass of all the visible stars and gas within it. Then, he calculated the mass needed to hold the cluster together based on how fast the galaxies were spinning. The numbers didn't match. Not by a little, but by a factor of over 400. It was as if an invisible giant was holding the entire cluster in its gravitational grip. Zwicky called this missing mass Dunkel Materia, dark matter. For decades, it was a fringe idea, a ghost in the astronomical machine. But then, in the 1970s, another astronomer, Vera Rubin, found the same problem everywhere she looked. Galaxies were spinning so fast they should have torn themselves apart. The stars on the outer edges were moving just as quickly as the ones near the center, defying Newton's laws. It was like a merry-go-round, where the horses on the outside were keeping pace with the ones in the middle. The only explanation was that every galaxy was embedded in a massive, invisible halo of something. Zwicky's ghost was real. Today, we know that this dark matter makes up about 27% of the entire universe, the stuff we're made of. The atoms in you, me, the planets, and the stars only makes up 5%. We are the cosmic minority, living in a universe dominated by an invisible substance we can't see, touch, or directly detect. For half a century, the leading theory has been that dark matter is made of WIMPs, weakly interacting massive particles. These are hypothetical, heavy, slow-moving particles that don't interact with light, which is why they're invisible. We've built massive, incredibly sensitive detectors deep underground, shielded from cosmic rays, all in an attempt to catch a single WIMP bumping into an atom. We've spent billions of dollars, run experiments for decades, and found absolutely nothing, not a single definitive WIMP. The silence from these detectors has become deafening. It's forcing physicists to confront a radical and, for some, an unsettling question. What if we've been looking for the wrong thing entirely? What if dark matter isn't just a collection of boring inert particles? What if it's something far more complex? What if it's alive? Now, before you click away, this isn't science fiction. This is a serious idea being explored at the frontiers of physics and astrobiology. It's a hypothesis born out of the failure to find WIMPs and the sheer weirdness of the universe. The idea is called living dark matter, or sometimes a cosmological organism. The proposal comes from a group of respected physicists, including Caleb Scharf at Columbia University. They argue that we might be suffering from a profound failure of imagination. We assume that life must be based on carbon and water existing on rocky planets. But what if life can emerge from fundamentally different building blocks? What if over the course of 13.8 billion years, the universe has found a way to organize dark matter into something complex, perhaps even something that could be considered alive? Think about it this way. On Earth, life is a complex system that processes energy and information to maintain a state of low entropy, a state of high order. A bacterium, a tree, a human being, we all fight against the universe's tendency toward disorder. The living dark matter hypothesis suggests that a similar process could occur within the vast cold halos of dark matter surrounding galaxies. These halos aren't uniform blobs. They have structure. They have streams and clumps and subhalos. Could these structures be more than just the result of gravity? Could they be analogous to the organs and tissues of a cosmic-scale life form? It sounds wild, but let's break it down. Any form of life, as we understand it, needs a way to store information, like our DNA, and a way to harness energy. Could dark matter particles have properties we haven't even dreamed of? Maybe dark matter particles can form long, complex chains, capable of storing vast amounts of information. Maybe they can interact with each other in ways that create a kind of dark chemistry. And what about energy? The universe is flooded with it. The living dark matter organism could be feeding on the energy from annihilating dark matter particles, or perhaps it's harnessing kinetic energy from the motion of stars and gas that pass through it. We see stars moving in strange, unexpected ways within our own galaxy. The Gaia Space Telescope has mapped the precise movements of billions of stars, revealing streams and groups of stars moving together in ways that our current models of the Milky Way can't fully explain. We usually attribute these to ancient galactic mergers, the gravitational ghosts of smaller galaxies our Milky Way devoured. But what if some of these disturbances are not ghosts? What if they are the result of interactions with a vast, complex, living dark matter structure that permeates our entire galaxy? What if the galaxy itself is, in a way, an ecosystem, and we are just the visible fauna living within a much larger, invisible biome? This leads to an even more mind-bending idea. If dark matter can become complex enough to be alive, could it also be intelligent? Could the universe be home to a form of intelligence so ancient and vast that it exists on a scale we can barely comprehend? A thinking, processing entity made of the very stuff that holds our galaxy together. An intelligence that doesn't use brains or neurons, but the complex gravitational and particle interactions within its own dark matter halo. It might not be conscious in the way we are. Its thoughts, if you could call them that, might unfold over millions of years. A single thought could be the process of redirecting a stream of stars or adjusting the gravitational potential of a region of the galaxy. Its goals and motivations would be utterly alien to us. Perhaps its goal is simply to maintain the stability of the galaxy, its home, and its body. This actually offers a potential solution to another great cosmic mystery, the Fermi Paradox. The paradox asks, if the universe is so vast and old, why haven't we seen any evidence of other intelligent civilizations? Where is everybody? Well, maybe the most advanced life forms aren't building spaceships or sending radio signals. Maybe they ascend to a new level of existence. Maybe they learn to manipulate the fundamental fabric of the cosmos. What if a sufficiently advanced civilization learns to transfer its consciousness from its fragile biological substrate, its bodies of carbon and water, into a more robust and permanent medium?
What if they become one with the dark matter halo of their galaxy?
They would become immortal, godlike beings operating on a galactic scale. They wouldn't need to communicate with us because we would be, from their perspective, like mayflies buzzing around for a day. Our entire civilization's existence would be a momentary flicker. This is where the 2025 discovery comes in. Not a real one, but a plausible future scenario that scientists are genuinely preparing for. The next generation of telescopes, like the Vera C's Rubin Observatory, named after the pioneering astronomer, and the Nancy Grace Roman Space Telescope, are set to map the universe with unprecedented precision. They will measure the effects of dark matter through gravitational lensing, where the gravity of a dark matter clump bends the light from a distant galaxy behind it. Our current models predict that dark matter halos should be relatively smooth, with some smaller clumps. But what if these new telescopes find something else? What if they find that the distribution of dark matter is far more complex and organized than gravity alone can explain? What if they find structures that seem to change or evolve over time in non-random ways? What if we detect a signal, not in radio waves, but in the subtle gravitational fluctuations of space-time itself, a signal that looks artificial? This would be the equivalent of Zwicky's discovery, but 1,000 times more profound. It would be evidence not just of missing mass, but of missing complexity. It would suggest that the invisible scaffolding of our universe is not just inert matter, but an active, dynamic, and perhaps even living system. We would be like jungle explorers who, after studying the trees and the rivers for years, finally realize that the entire forest floor is covered by a single massive fungal network, a hidden organism connecting everything. Our entire conception of the cosmos and our place in it would be shattered and rebuilt overnight. The search for extraterrestrial intelligence would shift from listening for radio signals from distant planets to trying to understand the language written in the motion of stars and the bending of light right here in our own galactic backyard.
Of course, this is all highly speculative. The simplest explanation is usually the right one, and the simplest explanation is still that dark matter is just a new kind of particle we haven't found yet. But the history of science is filled with moments where the simplest explanation turned out to be wrong, and where a radical new idea opened up a whole new reality. The idea that the Earth revolves around the Sun was once a radical, dangerous idea. The idea that matter is made of tiny, invisible atoms was just a philosophical concept for 2,000 years. The idea of living dark matter pushes our imagination to its absolute limits. But in a universe where 95% of reality is hidden from us, we need that kind of imagination. We need to be open to the possibility that the cosmos is not just stranger than we imagine, but stranger than we can imagine. The ghost that Fritz Zwicky saw in his telescope almost a century ago might not be a ghost at all. It might be the largest, oldest, and most mysterious living thing in the entire universe, and we are living inside of it. Thanks so much for watching. What do you think? Is dark matter a boring particle, or could it be something more? Let me know your wildest theories in the comments below. And if you enjoyed this journey into the unknown, don't forget to like and subscribe for more cosmic explorations. See you next time.